So after that, we can look at some case studies. For example, we can have a case study that a bank is losing customers, right? So when we want to analyze the situation, when your bank is losing your customers, how do we realize this fact? By looking at the pattern that attrition rate is greater than acquisition rate, right? So the rate of acquiring assets is less and the rate of selling assets is more. And of course, more profitable customers seem to be the ones to go. So for example, people with large investment, if they are going from your bank, of course, you are losing customers. And since large balance has been withdrawn by these customers that were more profitable, the bank is losing more money. Another case study that can be the Bank of America. Bank wants to expand its portfolio of home equity loans, right? So the bank wants to have more home equity loans for its customers. But the problem is the direct mail campaigns have been disappointing. Nobody is taking the loans just by direct mail campaigns. So what to do, right? So data mining can help in these situations by uncovering the patterns. So now we can look at the virtuous circle of data mining. It's a pun equating the use of the vicious circle, right? So we don't call it the vicious circle of data mining. Since we are great fans of data mining, we say it's a virtuous circle. So what do we mean by that? The data mining would help us identify the business problem, and we'll use the data mining to transform the data into actionable information. So we'll use data mining to interpret the data, to find out what's going on in our business and how can we improve the business. So the first point is, what is the right data and where do we get it from? Of course, as far as this point is concerned, we are also dealing with the cleansing of the data, right? And we are dealing with the standardization of the data. Remember, in data warehousing, we looked at the fact that data would be pre-processed, right, cleansed, so that we can have useful meaning by using the process of data mining. But of course, we must know for the data mining what are the right techniques that we can use for the data mining, as there are many techniques that are used. So once we have got our data and once we have got the actionable information, we act on the information, right? And after acting on the information, we'll measure the results. So this is how basically how the data mining operation works. We'll first identify the business problem, then we'll use the data mining method to interpret the data into actionable information, and after that we act on the information and then we measure the results. So now let's look at some business uses of data mining. Essentially, as data mining is concerned, there are basically essentially 6 tasks. One of the tasks is classification. We might have an application for credit customers and we can classify them as low, medium and high risk. So this kind of data mining application would be classifying our credit card customers or applicants as being a low risk customer, a medium risk customer or a high risk customer. Similarly, we can classify the insurance claims as normal and suspicious. So we are classifying an insurance claim would either be a normal claim or a suspicious claim. Also, a credit card applicant can be classified as a low risk, medium risk or high risk. Then we can have the estimation, and in estimation we estimate the probability of the direct mailing response. So we can estimate what would be the rate of or likelihood or probability of getting a direct response from a direct mailing. We can also estimate the lifetime value of a customer. We can also do prediction, and by prediction we predict which customers will leave within 6 months. We can identify patterns for customers that are leaving us, and using that information we can predict customers that would be leaving us within 6 months. We can also predict the size of the balance that will be transferred by a credit card prospect customer. So these are called predictions. Now we can look at some of the business uses of data mining, and we can start with the first use, which is affinity grouping, right? And this affinity grouping is something very common, right? We find out what customers are likely to buy together, right? And this is common phenomena in major e-commerce sites. Amazon says customers who bought this also bought this. So this is basically affinity grouping. We can also use affinity grouping to find out what books to recommend to Amazon.com users. Then we can have clustering, and clustering is different from classification. We create clusters of like groups, right? Like agents or like people. So by clustering we create clusters of similar groups. We might know what those classes would be, but whatever the class, we combine agents of likely preferences. Then we can have description. We can describe data, which would help us understand large volumes of data by uncovering the interesting patterns. We look at all of these techniques as we move along. So now we look at some of the overview of the data, some data mining techniques. One can be market basket analysis, which is a very popular tool. Then we have memory-based processing, which is called collaborative filtering, automatic clustering, which is creating clusters of like objects, decision trees and rule induction, and of course one of the most popular techniques, neural networks or artificial neural networks, or in image processing we can use convolutional neural networks or CNNs. So now we can look at this market basket analysis technique. This is basically association and sequence discovery technique. So what are the principal concepts? Support or prevalence, which is the frequency that a particular association appears in the database. Then we have the confidence, which is the conditional predictability of B given the predictability of A. So we can take a look at an example which would make many things clearer. For example, total daily transactions is 1000, number which includes soda is 500, number which include orange juice equals 800, and number which include both soda and orange juice is 450, right? So we can calculate support for soda and orange juice, which is basically predictability of A union B. If soda is A and orange juice is B, so the predictability of A union B. Okay, so what is the probability of A union B? Is soda and orange juice, it is 450. And what were the total transactions? 1000. So support for soda and orange juice is probability of A union B, which is 450 divided by the total transactions 1000, which is 45%. Similarly, we can now find the confidence of soda given orange juice, right? The confidence of soda given orange juice can be found by using this formula. So what is confidence of soda given orange juice? It can be given by the predictability of soda and orange juice, which is 450, divided by the predictability of soda, which is 500, which is 450 divided by 500, which is 90%. Similarly, confidence of orange juice given soda can be given by the predictability of soda and orange juice, which is 450, divided by the predictability of orange juice, which is 800. So 450 divided by 800, this is 56%. So this is how this example is dealt with. So we can apply the market basket analysis to create a co-occurrence matrix, and we can find out what is the right set of items. So we can generate useful rules, and we can weed out trivial and inexplicable from the useful, right? So we can figure out how to act on them. So one of the very good reasons of applying market basket analysis can be, for example, if people are buying milk and butter together, so we can place milk and butter on closed shelves one after the other, so that it is easier for the users to buy milk and bread. Similar techniques can be applied to time series for mining useful sequences of actions. Again, we are going to be discussing these things in detail later on. We can now look at memory-based reasoning briefly. It helps to predict unknown attributes of customer situations based on attributes on their nearest neighbors. So this technique is called nearest neighbor technique. This is one of the algorithms that can be used for memory-based reasoning. So the principal set of techniques behind web recommendation engines. Which technique? Memory-based reasoning. Otherwise, we can also known as collaborative filtering. So Amazon.com book recommendations work on this. For example, identify books to recommend to customers. Company keeps log of past customers' purchases. So it represents each customer as a vector whose components are the past purchases, right? So we can define a distance function for comparing customers. Based on this distance function, we identify the customer's nearest neighbor set, or NNS. So we identify books that have been purchased by a large percentage of the nearest neighbor set, but not by the customer, and we can recommend these books to the customer as a possible next purchases. So this is how basically this technique can work. So based on a certain customer and its past customer purchases, we define a vector, and we define a distance function for comparing customers, and when this distance is smallest between a cluster of customers, so we can recommend the books that were bought by this cluster to their particular customer. So we are going to be looking at this example in detail. Another example has been provided, which is a personalized restaurant recommendations, right? Alice is the person who is asking Zagat.com for a personalized rating of Border Cafe, right? So Alice has already submitted ratings for 20 other restaurants in the past 12 months. But the Zagat.com finds other members whose ratings for those 20 restaurants are similar to Alice's. So Zagat.com calculates the average or weighted average rating that these nearest neighbors have given to Border Cafe. And this is Alice's personalized rating of Border Cafe. So again, the nearest neighbor between the other reviewers and Alice's review is going to be basically be forming the personalized rating, right? So this is not equivalent to the average rating of Border Cafe based on the entire population of the raters. It is only the ratings that are similar to Alice's ratings. So the distance between Alice's rating and all those persons' ratings is small or near. Then we can talk briefly about clustering. Clustering divides segment a database into groups. And what is the goal? We find groups that are very different from each other and whose members are similar to each other. So you find different groups which are different from one another. The one group A is different from group B, but people of group A, members of group A, are similar to other members of group A, and members of group B are similar to other members of group B. But of course, number and attributes of these groups are not known in advance. It is formulated at runtime. So this is an example of a clustering example, right? We have created one cluster over here, and we have created one cluster over here. So members of the cluster are similar in their attributes, and members of this cluster are similar in their attributes, right? But this cluster A's attributes and members are different from the attributes and members of cluster B. So this is how it goes. Then we can have decision trees. Of course, based on the decisions we move down the tree. If income is greater than 40,000, right? Then if job is greater than 5 years, we define low risk and high risk. Again, if income is greater than 40,000 and high debt, then we can have high risk and low risk recommendations, right? So this thing, a decision tree is created. So data mining is used to construct the tree. An example algorithm is the CART algorithm, classification and regression trees.